Hello everyone, today we are going to work on this earth material. So it's like that I am on the moon at the moment and I'm seeing the sky, so that's why I have turned down the gravity and kind of made a slow motion effect to make it look like I'm in a low gravity planet. So yeah, here is the material. So if as you can see, these clouds are slowly moving and we have some shining effect across the edge, and also there is this night map in the dark area too. If I change the light direction, you can see it clearly. So yeah, let's see how to implement this effect today, this material today, including how to slow down the character, the world time and gravity, but that's just a bonus. Main part is the earth material. Right, so this is the same project where we worked on this earth material. So sorry, not earth material, the moon material. Let me duplicate this map. Okay, so this is the same project where we worked on this moon and Jupiter, this one, and the sun. Here is the sun. So let me duplicate this moon map. Copy. I name it as Earth. Right, now let's assume that we are on moon looking at the earth. So I'm going to replace this material with the earth material, but in the moon we don't have clouds. So let's remove this volumetric cloud first. You can't clearly see the clouds because it's pretty dark. So let me just, here you can see slightly the clouds, so let me just delete it. Now we don't have clouds. Great, so we can really see the Milky Way, by the way. Okay, now under materials, create a new folder. Earth, and I have already downloaded this day map texture, night map texture, clouds texture, normal map texture and specular map texture. You can download it from SolarSystemScope.com textures/textures, this URL. So yeah, let me import them. I have already downloaded. Let me just drag and drop. Great, so here we have the basic color map, day map, and the clouds, night map, and this is specular map. So white means the sea, and the normal map. Okay, so let's create a material. Earth, and I'll assign that material to this. So you can't see it clearly because it's pretty dark. If I increase the directional light intensity, you might see that like this. Okay, sun is not visible. Right, maybe we should leave it like this. Okay, but I am going to keep the sun intensity lower because I want to have a darker environment. It looks nice in dark environment. And let me open the earth material. So here let me drag and drop this normal map and specular map. I'm gonna use other maps also later, but let me just connect this specular map. Let's connect. Great. So we see the shining in the sea, but not in other areas. Normal map also, let's connect. Okay, let me turn on the detail lighting. So actually normal map is not very strong. It's because in this scale we shouldn't get that strong normal map effect, so it's fine, right? But still in this map it's not visible enough. So let's have some emissiveness as well, just like we did in the moon material. But if you remember, if we just connect it like this, it becomes visible, but it completely becomes like an unlit material, which is not cool. So we can do the same calculation we did yesterday. Sky, atmosphere, light direction to dot product with the pixel normal WS, and result of this multiply with the base color, plug it to the emissive color and apply. So you can see this area is lighter, this area is darker, so we get this effect here also. But still somehow this does not look good. Let me increase the lightness, light intensity of the direction light and move it up. Okay, and when we are at the moon, we don't have an atmosphere, so we should not get this blue scattering. So sky, atmosphere, Rayleigh scattering, what's the default value? Let's make it dark, right? So yeah, now it looks actually like in the moon. Let's adjust the sun a bit so we can see more of the earth. Great, I think this angle looks great. Let me rotate it to see more land. Great. Let me send to my country, which is Sri Lanka. Okay, what else now? So now that we can, since our direction light intensity is high, we can see some shininess in here, see, in the sea. Okay, now the next part is getting this cloud and after that let's cloud this one. After that let's work on night map. So to get clouds, so to add clouds, let's add these two textures together. Base color, day map or day map, and the clouds. Let's put it in here. Right, and the same should go to this emissive calculation as well. Apply. Right, now we can see the clouds. Okay, and if we need to give a movement to the clouds, we can simply add a panel here and connect text code, texture coordinate, then speed X. No, that's too much. 0.1. It's not updated. Let's see here. That's still too much. Is there a flickering here? There is some flickering, but I'm not sure why. Okay, let's turn down the speed, maybe 0.4. Still too fast. Alright, I think that will do. Okay, so the next part is getting the night lights. To this shadowed area. So first let me drag and drop the earth night map. This is the night map. Right now here let's use a linear interpolate between the output of this one and this texture. As the alpha value, we can use 1 minus of this, because if I preview this, you can see this area is dark, this area is white. This area means the area that I get the shadow. So if I add a minus value like 0.2 here, minus value, that dark area becomes wider. To be safe, let me clamp this in between 0 and 1. Now if I preview this, I get either this night light or this light area, day map. Let's put this as the emissive color. Apply. Right, now if I rotate the sun to get some more darker area, you can see the night lights now we do get here, but we the other area is not dark enough. So to prevent that, we can do something like this. If we want to increase the intensity of these lights and make the dark areas darker, we can use a power node. See, now the dark area becomes darker, light areas become lighter. Okay. Great. Now if we want more light, if we want to increase the light intensity, what we can do is we can multiply this with, let's say, 5. Now lights are more visible. Right, but here also we get the lights then. Let's try to it seems cool. If I adjust this value, instead of -0.2, what if I use 0.4 or 0.6? By doing that, we can push the boundary where we get the lights. Right. Okay. Right. Let me keep it like this and also rotate this a bit. Right, now the only thing missing is some shining effect across this edge to give that atmosphere, thick atmosphere like feeling on this planet surface. So to get the shining effect across these edges, actually I've been using this calculation previously, but one of the subscribers mentioned that we could easily use Fresnel for that. So yeah, let me try Fresnel here. Let me preview this node. So with the Fresnel, this is the kind of value what we get. So if I increase this, what happens? Nothing. Decrease. So we can this is the kind of shape we need. If I increase this one, this edge becomes thinner, but 5 would work. Now if I multiply with this value, we can avoid white in the shadow area. Let me work with this. See, now there is no white in the shadowed area. Okay, and now let me plan this between 0 and 1, because I am going to add a multiplier here, another multiplier to boost the emissiveness, and this multiplier will be selected from a lerp linear interpolate. First one should be 1 because there is no boosting. Then I don't know, 500. So these values will be selected based on this output. And if I stop previewing this, so we can get, now you can see we get extra brightness in the surface where we hit sunlight. Maybe it's too much. We can easily turn it down by, maybe we should reduce this entire area. Let me set this to 10. That's better. Also, if you want to further reduce the brightness we get closer to the dark side, we can do this. Here we can subtract, not 1, maybe 0.3, 4.5. Now only a limited area would get the brightness. Let's see. See, now only this area we have the brightness where I directly hit the sunlight. Okay, so I increase this value just to see how it looks, and I think the way it looks now is good enough. Right. Total debug camera. Okay, so this is the final look of the Earth, and if I detach from the controller and rotate this, oh, is it completely rotated? Yeah, let me reset. Alright, so this is how it looks. Let me change the sun direction and check as well. Great. Okay, everything works as intended. I think this is the angle. We see Earth in this angle in few popular photos. Okay, so I'm gonna stop this episode right here, and thanks for watching. As always, project files will be available in the Patreon page for the download. Link would be in the description below, and if you like to support my work, you can get the membership of the Patreon club. See you in another episode. Goodbye. And one more thing before I go. So a quick way to get a moonlight effect, we can do something like this. Let's go to the level blueprint. Here, set global time dilation to 0.6, try 0.5. Now with this slow effect, it already feels like we are on the sun or on the moon. See? Also, what if we reduce the gravity? Yeah. What's the gravity of the moon? Gravity 1.62 ms. Earth 9 point. Yeah, 1.62. So if I make this 1.62, right? Yeah, this much. Oh, that's too much. Yeah, that's too much. We need to make it look better, don't want to make it accurate, because also this mannequin can jump more than a normal human. Okay, so yeah, that's it. I'm gonna stop this episode right here.